In today's lesson, we'll be going over 5.5 properties of quadrilaterals. Now, most of what we'll be referencing will be from your lab packet and or from page 241 and 242. So as we're going through these proofs, as you're doing problems in class or in homework, make sure you're looking at those properties and knowing them really well. I have them listed out, so I'll kind of reference them on the screen as we're going through. But again, your lab packet and those 2 pages are going to be extremely helpful as we go in solving and proving certain quadrilaterals with the properties. Let's start with this example right here. We're given VRST is an isosceles trapezoid with legs VR and TS. And what we're trying to prove is ARS, and A is actually where they intersect, is an isosceles triangle. So let's look at what some of the properties of an isosceles trapezoid are. The first thing is that the legs are congruent. We also know that the bases are parallel. We know that the lower base angles are congruent, as well as the upper base angles congruent, and the diagonals will always be congruent. And any lower base angle will be supplementary to any upper base angle. So let's go back and look at the diagram to see which one of these might help us in proving ARS is isosceles. So looking at ARS right here, to be isosceles, a good guess would be that AR or AS and AS would be congruent, or this angle down here would be congruent to this angle down here. Now, based on what we just saw about the properties of an isosceles trapezoid, none of those properties directly give us to that conclusion. So let's maybe look at a bigger picture. And again, if we look at the bigger picture, we see that this angle right here, which could prove the isosceles triangle, is also a part of this bigger triangle, as is this right here, and those lower base angles would be congruent. So now looking at those triangles and thinking about the properties of an isosceles trapezoid, we know that the legs are going to be congruent, and the legs in this case are VR and TS. So those are going to be congruent. We also know that RS is going to be reflexive on itself. It both overlaps the sides of both the VRS triangle and the TSR triangle. If we continue to look at the diagram and also think about the properties of an isosceles trapezoid, you can also see how this bigger angle right here of the triangle and this bigger angle of the green triangle are the lower base angles of the isosceles trapezoid. And again, one of the properties of an isosceles trapezoid is that the lower base angles are congruent. So we can prove VRS and angle TSR are congruent, which will then supply us enough information to say that the 2 triangles themselves are congruent, based on side angle side. Now that we established that the triangles are congruent, what that does is now the corresponding part, which are now these lower angles, which are part of our isosceles triangle that we're trying to get to right in here. You can see that. So this triangle, and again, hopefully you can see now those minor angles in there are congruent based on corresponding parts of congruent triangles being congruent. And then that's the definition of isosceles triangle, and we've now proven that. Let's now take a look at our second example. We're given that PHJM is a rectangle, and we're also given that PG is congruent to MK. And what we're trying to prove is that OGK is isosceles. Now, one bet would be to assume, since we have congruent segments down here, that it's probably a good bet that either angle G and K are congruent, or these segments are congruent in order to prove our triangle isosceles. So now let's think about the properties of a rectangle that can help us lead to those possibilities. The properties of a rectangle being all the properties of a parallelogram, so we'll reference that in a second, all angles are right angles, and that the diagonals are congruent. And the properties of a parallelogram being the opposite sides are parallel, opposite sides are congruent, and the diagonals bisect each other, along with any pair of consecutive angles will be supplementary. So now let's figure out which of these properties might help us. Well, if I'm trying to prove the angle's congruent, it might be a good bet to try to get this triangle congruent to that triangle. And in order to do that, I will need this side and this side of the triangle, and maybe possibly this angle if I can figure that out as well. One of the properties of being a rectangle are the opposite sides are congruent, as well as falling into a parallelogram. So PH is congruent to JM, but we also know, being properties of a rectangle, is that all the angles are right angles. Therefore, PHJ and MJH are going to be right angles. The reason we do this is that we can see that they're supplementary to the other angles within that triangle, which will help us prove congruent in just a few steps. So now from that information, what we can say is that angle PHJ is now going to be congruent to angle MJH. And then we can also say that angle PHJ is supplementary to angle PHJ, along with angle MJH and MJK. From there, we can say that angles PHG and angles MJK are right angles based on the theorem, if supplementary and congruent, then they are right angles. Now, what this now does is this creates the two triangles congruent based on the HL property. We have the hypotenuse congruent, a legs, and now a right triangle, or a right angle. Therefore, angle G will be congruent to angle K based on CPCTC, and therefore the triangle OGK will be isosceles since the two base angles are congruent.